As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So, hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For a comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called super-Jupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP 103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b, not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next?
It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to… But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing. A star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you move this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What of you? Discovered in 2017, KELT-9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT-9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
Bang! Or should I say, Big Bang? The Big Bang. Ahem. So, after the Big Bang, the universe resembled a hot soup of protons, neutrons, and electrons. After it started to cool down, the protons and neutrons began to combine, first forming ionized atoms of hydrogen and later some helium. These ionized atoms of helium and hydrogen attracted electrons, turning them into neutral atoms. As a result, the light was able to travel freely for the first time ever, since it was no longer scattering off free electrons. What does it mean? The universe was no longer dark. At the same time, it was still about a few 100 million years after the Big Bang before the very first sources of light started to appear. That's when the cosmic dark ages came to an end. We don't know for sure what this universe's first light looked like or how the first stars formed. Luckily, we have the James Webb Space Telescope to help us find the answers. How come? All because this is an infrared telescope. Why is it important? Let's figure it out. Imagine a star. It's a very, very old star, maybe the first star out there. Light leaves this star 13.6 billion years ago and settles off on an incredible journey through space and time. It needs to get to our telescopes. By the time this light reaches us, its color or wavelength shifts towards red. That's something we call a redshift. It happens because when we talk about very distant objects, Einstein's theory of general relativity comes into play. According to it, the expansion of the universe also means that the space between objects stretches, making them move away from one another. But that's not all. Light stretches too, which shifts it to longer wavelengths. Eventually, this light reaches us as infrared. In other words, redshift means that light that is originally emitted by the first stars or galaxies as ultraviolet or visible light gets shifted to redder wavelengths by the time we catch a glimpse of it here and now. For the farthest objects with very high redshift, that bare minimum of visible light is shifted into the near and mid-infrared part of the electromagnetic spectrum. That's why to see those space objects, we need a super powerful telescope. And if we talk about the Webb telescope, it can see back to about 100 million to 250 million years after the Big Bang, which is incredibly awesome. So by observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that formed in the early universe. To look that far back in time, we need to look deeper into space. All because it takes light time to travel back from there to us. So the farther we look, the further we glimpse back in time. To find the first galaxies, James Webb is going to make an ultra-deep near-infrared survey of the universe. Then it'll follow it up with a few other methods of research. Now, as you remember, the gas between stars and galaxies in the early universe was opaque, and energetic starlight couldn't penetrate it. But then, about 1 billion years after the Big Bang, it suddenly became completely transparent. Why? The James Webb Telescope might have found the reason. At one point in the past, the first galaxy's stars emitted enough light to ionize and heat the gas around them. This helped clear the view over hundreds of millions of years. The newest insights scientists got were about a time period called the era of reionization. That's when the universe underwent some dramatic changes. After the Big Bang, gas in the universe was unbelievably hot and dense. Hundreds of millions of years passed, and it cooled down. But then, something baffling happened. It was as if the universe hit the repeat button, and the gas became ionized and hot once again. It could have happened because of the formation of early stars. After that, millions of years later, this concoction became transparent. For a long time, researchers have been hoping to find definite evidence that could explain these changes. And now, the telescope has finally shown that those transparent regions are located around galaxies. Astronomers have seen these galaxies reionize the gas surrounding them. Even better, they've managed to measure how large these transparent regions are. They're ginormous compared to the galaxies themselves. Imagine a hot air balloon, and now imagine a pea floating inside. You've got it, and guess what? These tiny galaxies drove the entire reionization process, clearing huge regions of space around them. These transparent bubbles kept growing until they merged and caused the entire universe to become transparent. The research team chose to target a period of time before the end of the era of reionization. At that time, the universe was not quite opaque, but not quite clear either. It was a patchwork of regions of gas in different states. To find out this cool fact, the astronomers aimed the James Webb Telescope in the direction of a quasar, an incredibly bright space object. It acted as a giant flashlight, traveling towards us through different regions of gas. It was either absorbed by the patches of near opaque or moved freely through the areas where the gas was transparent. The scientists then used Webb to examine galaxies in that region of space. They found out that these galaxies were usually surrounded by transparent regions with a radius of about 2 million light-years. For comparison, the area the galaxies cleared was almost the same distance as the space between our home Milky Way galaxy and our nearest neighbor, the Andromeda Galaxy. And the telescope witnessed those galaxies in the process of clearing the space around them. It was the end of the era of reionization. Until then, no one had evidence of what caused reionization. The team is planning to dive into research about other galaxies in 5 additional fields. The Webb telescope's results from the first field have been overwhelmingly clear. And even though the astronomers had expected to identify a few dozen galaxies existing during the era of reionization, they actually managed to spot 117. Now, let's talk a bit about the main hero of today's show, the James Webb Space Telescope. It's an absolutely stunning piece of equipment which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally the cost of the telescope was estimated to be just $1 to $3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope, and it was another $1.1 billion to fix it in orbit. Even though the James Webb Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are less than 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than minus 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool.
So, a planet a few times bigger than Earth, where actual diamonds fall from the sky like rain, it already sounds pretty sci-fi. But trust me, that's not even the strangest part of the story. You see, scientists recently pointed the James Webb Space Telescope toward this world with a name that looks like my driver's license, and found out that it ignores many rules. Most planets, just like Earth, circle normal stars like our Sun. But the Diamond planet, let's call it like that, circles a pulsar. This world circles something far scarier than a normal star. A pulsar, a type of neutron star. Pulsars are born when the massive star collapses and a supernova goes boom and wipes out all nearby planets. And even if those planets don't stop existing immediately, radiation literally strips material off of the companion star over time. Bit by bit, the pulsar eats it alive, like a cosmic cannibalism. But the new mysterious object isn't a star, it's a planet. and planets shouldn't survive anywhere near that kind of radiation or evolve into something chemically bizarre. But anyway, the pulsar that the Diamond Planet lives next to spins insanely fast and fires beams of radiation like a cosmic lighthouse made of gamma rays. Normally, stars blind telescopes when scientists try to study nearby planets, but pulsars don't shine much in the infrared light, the kind the James Webb Space Telescope detects. So, astronomers could see the planet glowing while its deadly parent, the pulsar, stayed almost invisible. They noticed that its mass, radius, and temperature are pretty normal for a so-called hot Jupiter. That's one of the rarest types of exoplanets. But then, things got weird. Well, weirder. First off, not so many pulsars we know of host exoplanets, and none of those planets scientists have spotted so far are gas giants. Second, the Diamond Planet shape is pretty weird. Because it orbits its pulsar at a distance of just around 1 million miles, it's really affected by its gravity, and that's why it has its unusual lemon-like shape. But the weirdest thing is the planet's atmosphere, which contains huge amounts of helium and carbon molecules. That carbon is floating freely instead of bonding with oxygen or nitrogen, like it usually does. Under temperatures between about 1200 and 3700 degrees Fahrenheit, carbon shouldn't survive in that form at all. On almost every other world astrophysicists know of, it quickly links with other elements. But our weird planet just ignores that rule completely, and none of the well-studied exoplanets act like this. It looks like the pressure deep inside this diamond world squeezes carbon so hard that it turns into diamonds, and they constantly fall toward the core like glittering hailstones the size of mountains. Scientists still don't fully understand what's happening with this diamond world. They tried comparing it to something called a black widow system. It usually has to do with two objects locked in orbit, a dense pulsar and a smaller companion star, similar to our Sun but much brighter. The Diamond Planet shows overwhelming amounts of carbon, far more than physics tells us is possible. It doesn't look like it formed like a normal planet from leftover dust and gas, and it doesn't seem like it formed from a star that got stripped down by a pulsar. So, as of now, it doesn't fit into any known formation scenarios. The pulsar may have erased a former companion star so completely that only an ultra-dense carbon core survived. Another idea is that extreme radiation reshaped an existing planet over millions or billions of years. Meanwhile, while scientists are solving this mystery, let's visit Uranus, where it also rains diamonds. Deep inside this ice giant, temperatures climb above 12,000 degrees Fahrenheit according to mathematical models, and pressure rises millions of times higher than Earth's atmosphere. Methane gets crushed until its molecules snap apart. The freed carbon atoms cling together, form crystal structures, and grow into diamonds. Those diamonds sink deeper, melt in hotter layers, rise again, and repeat the cycle endlessly. And not only that, the James Webb Telescope showed that Uranus's magnetic field tilts about 60 degrees off balance, which means the planet's invisible magnetic shield sits crooked compared to its rotation. On Earth, auroras stay near the poles, but Uranus spreads glowing auroras across huge regions of its atmosphere. Webb watched the planet spin for 15 hours, which is almost a full Uranian day, and captured massive energy flows moving through the upper atmosphere like glowing weather systems powered from deep inside the planet itself. All this means that ice giants distribute heat in ways we barely understand. Uranus almost rolls sideways as it orbits the Sun, and that strange orientation seems to twist how charged particles move through its atmosphere. Instead of neat polar light shows like ours, Uranus creates wandering auroras, also pronounced wandering auroras, that stretch across the planet like cosmic neon storms. Studying them can help researchers understand magnetic fields. It's a pretty big deal because they act like planetary force fields that protect atmospheres from space radiation. At the same time, another mysterious world has its own pretty weird weather system. I'm talking about Titan, Saturn's largest moon. Titan doesn't use water for rain or lakes. It uses methane, the same gas we burn for fuel on Earth. Scientists discovered that Titan's seas actually shape its local weather, just like the Great Lakes influence climates in North America. Liquid methane evaporates, rises, cools, and falls again as mist or rain. Warm air lifts upwards, while cool air rushes in behind it and forms convection cells, which are giant looping currents of moving air that drive storms. And not just regular storms we're used to. No! Titan has lake breezes, fog banks, and seasonal weather cycles that run on hydrocarbons instead of water. Titan's big brother, Saturn, doesn't just have weather. It throws atmospheric tantrums on a scale that makes Earth storms look like brief summer rain. When NASA's Cassini spacecraft orbited Saturn between 2004 and 2017, its instruments picked up lightning flashes so powerful they could shine even in broad daylight. On Earth, lightning already releases temperatures hotter than the surface of the Sun for a split second. On Saturn, some bolts carry 10,000 times more power than lightning here. Cassini even detected radio signals from these storms, which means researchers could literally listen to thunder rolling across another world. Some of these storms expand more than 190,000 miles wide, large enough to circle nearly the entire planet. Then there's Saturn's famous North Pole hexagon, a perfectly shaped six-sided jet stream spinning non-stop for at least 40 years since spacecraft first noticed it. Wind streams racing around the pole naturally lock into this geometric pattern. That hexagon stretches hundreds of miles deep into Saturn's atmosphere. Now let's hop onto Venus, where the climate spirals completely out of control. At its south pole, a spacecraft saw a massive double-eyed vortex, roughly the size of Europe, spinning endlessly in thick yellow clouds. Unlike Earth, where the atmosphere mostly moves together with the planet, Venus has something called superrotation. Its atmosphere races around the planet about 60 times faster than the surface below. Winds roar at speeds near 250 miles per hour. The surface temperature there is around 870 degrees Fahrenheit, hot enough to melt lead, zinc, and many spacecraft components. It's so hot because sunlight enters easily, but dense carbon dioxide traps outgoing heat so efficiently that cooling never happens. Even rain behaves cruelly there. Sulfuric acid forms high in the clouds and falls downward, but intense heat evaporates the droplets before they ever reach the ground, and rain just disappears mid-air. Well, our final stop of the day is Neptune. It receives only a tiny fraction of the sunlight Earth gets, but somehow drives jet streams exceeding 1,300 miles per hour, twice faster than the speed of sound. Heat must be rising from its interior to fuel such speeds. When Voyager 2 flew past in 1989, it spotted the Great Dark Spot, a storm system roughly the size of Earth itself. Neptune's storms appear and disappear within years, and behave like living systems that constantly evolve. Some of its storms drift toward the equator and then suddenly reverse direction. That never happens on Earth. So Neptune is another reminder that weather in space doesn't always follow familiar rules. Sometimes, physics builds systems so extreme that scientists can't explain them even after decades of observation.
Wow, the James Webb Telescope has been fully deployed! If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant, and elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there will be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge. comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sunshield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sunshield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephens Quintet. This photo was also posted on July 12th. Stephens Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even 2 moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant, swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Bruh. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future. They aren't supposed to exist. No one expected to find them. Scientists can't explain how they formed. And still, the James Webb Space Telescope has found them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. They're so far away from us that they look like tiny reddish dots, even to this extremely powerful telescope. Astronomers have analyzed the light coming from these galaxies and estimated their age. They appeared 500 to 700 million years after the Big Bang. So far, nothing surprising. Galaxies that young aren't exactly rare. Scientists think that our first star clusters could have sprung up soon after the universe left the so-called Dark Ages. Those were the first 400 million years of its existence. At that time, only a thick fog of hydrogen atoms filled the cosmos. What is extremely bizarre about these galaxies is their tremendous size and the age of the stars inhabiting them. But this doesn't coincide with the existing ideas about what the universe looked like. and how it evolved in its early years. Plus, it doesn't match with earlier observations made by the Hubble Space Telescope, Webb's less powerful predecessor. So, according to scientists, what are early galaxies supposed to look like? The answer is simple: young and small. And indeed, previously, most early universe galaxies we found were just space babies, blue and small. They seem to have appeared out of the primordial cosmic soup just recently, and were still building their early stars and other structures. Most young stars are actually blue. As they age, they acquire a reddish glow after burning through their star fuel and cooling down. That's why astronomers were not ready to see old red stars in those ancient galaxies Webb Telescope was built to discover. Another thing they weren't ready to spot was galaxies more massive than 1 billion suns, and still, it happened. The most massive galaxies discovered recently seem to have masses just twice or 4 times lower than that of the Milky Way. And the most astounding thing here is that these galaxies were already that big when the universe was a mere 3% of its current age. But before astronomers start rewriting their theories, trying to explain how such huge galaxies formed so fast after the Big Bang, we need to make sure that what we're looking at isn't some other space phenomenon. Even so, most alternative theories need totally new concepts as well. One of them goes like this. Perhaps stars in the early universe emit light in some unusual, exotic way. And since astronomers didn't know about it, they didn't include this possibility in their models. Or our understanding of how stars form might be inapplicable to the early universe. If any of these theories turns out to be true, it'll overturn our understanding of star formation altogether. Now, how about we talk about the device that helped astronomers to discover those bizarre galaxies? The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally, the cost of the telescope was estimated to be just $1 to $3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope. It was another $1.1 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are only 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than negative 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. JWST is believed to be able to detect water on distant exoplanets. For a long time, astronomers have been discovering planets orbiting stars outside of the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them, Plus, it's possible to read unique signatures in the light. This can tell us about a planet's chemical composition. And the strongest and most readable signatures happen within the infrared spectrum. And guess what? James Webb has state-of-the-art infrared instruments. They can help scientists spot new planets and even identify the presence of water there. The telescope was launched near the equator because Earth spins a bit faster there. And this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its lifespan. Interestingly, at first, astronomers were sure that finding something exciting with the help of James Webb would take time. They thought that the first discovered galaxies would be so small and dim that the telescope would only find some remote candidates at best. But it didn't go as planned. As soon as the first images were released, scientists started finding countless galaxies, bright, large, and impressively old. The competition is still on. One research group after another spots new record-breaking worlds. One astronomer even said that the scientific world was freaking out since no one had actually expected such impressive results. One of the main goals of the Webb telescope is to observe the light from the very first stars and galaxies in the universe. Unfortunately, the farther away an object is, the faster it's moving away from us. And the longer the light has to travel, the more it stretches towards the infrared side of the spectrum. This is called redshifting in astronomy. But thanks to its infrared equipment, James Webb can reveal previously invisible worlds to us. So, thanks to this telescope, we've managed to see incredibly distant galaxies that were born around 3.8 billion years ago. It means that the light JWST detected took more than 13 billion years to reach Earth. Can you imagine that? But one of these galaxies stands out from the rest. It appears to be the oldest galaxy astronomers have discovered so far. It's called Glass Z13, and it dates back to a mere 300 million years after the Big Bang. The previous oldest galaxy scientists identified was found by the Hubble Space Telescope, and it dates back to 400 million years after the Big Bang. During that scarcely probed era, the very first galaxies and stars started to appear. But how exactly did this process unfold? No one knows for sure, yet. It might have depended on the laws of some exotic physics, including the influence of dark matter and dark energy, or some poorly investigated communication between gas, dust, and starlight. With the help of the Webb telescope, scientists can now test their theories about what was happening out there after the birth of the universe.